Here you are asked to simplify expressions with exponents. A key thing here is that you cannot have a negative exponent in your final answer. So you need to remember that if you have a negative exponent, you have to take the reciprocal of that. So if it starts in the numerator, it moves to the denominator. If it starts in the denominator, it moves to the numerator. Okay, so for the first one, we have x to the 5 times x to the negative 2. This is a product because we are multiplying the two values together. Sometimes you'll see a dot in between them. You may see parentheses, or they may be sitting right next to each other. All of those are products or multiplication. So the product property of exponents says that you add them together. To show your work on this, you get x to the 5 plus negative 2. Well, 5 plus negative 2, or 5 minus 2, is x to the 3. So that is your final answer. Okay, so now for the next one, we just have more things. We have a couple of numbers, we have a couple of terms with x's, and as well as a y. So we want to combine what we can first. I always start with my numbers. So here I have 4 and 3. And again, they're all sitting right next to each other, so this is multiplication. So I get 4 times 3 is 12. I'm done with those numbers. Then I have x to the 3 times y to the 5. I'll show the work here. So the product property says that I add my exponents together. So those are now done. And then I have y to the negative 2. I'm going to leave that there for the moment. But to remind myself what I actually have here, I'm putting it all over 1. Anytime you have a whole number, or anytime you don't see a denominator, you have a denominator of 1. Okay, so now I'm going to go combine. So I have 12, x to the 3 plus 5, which is x to the 8. Now, in order to turn y to the negative 2 positive, I need to move it down below. It started in the numerator, so it needs to move to the denominator. So I get y squared. So this is my final answer. Here the complexity is increasing. We just have another property to use, and then a few more variables and numbers to use as well. Okay, so for the first one, we have parentheses around a whole bunch of things with an exponent of negative 2. So ultimately, we're going to be using the power property of exponents. So whenever you see a negative or positive exponent on the outside of parentheses, it means the power property. And the power property you multiply your exponents. Now, often what is forgotten is that if you don't see an exponent, there's still a 1. So I would recommend placing a 1 on any value that does not have a visible exponent, because you're going to have to distribute the negative 2 to everything on the inside. Now, the other thing that I would do is double check whether there's anything I can combine in parentheses. In this case, I have no common bases. I only have a 2, so there's nothing I can combine. So I'm going to go ahead and use the power property, which says I need to distribute the negative 2 to every exponent. Okay, so I get 2 to the negative 2, because again, that 2 has a 1 on it. Then I have b, negative 3 times negative 2 is 6. C to the 2 times negative 2, that's c to the negative 4. And d to the 1 times negative 2, which is d to the negative 2. Okay, now this is not my final answer because I still have negative exponents. So for the next step, what I recommend is to draw a line. Okay, and remember that all of this is over 1. So now I'm going to place everything that has a positive exponent on where it is already. So in this case, the only positive exponent I have is b to the 6. So I'm going to place that, b to the 6. I'm done with that. And now I need to move everything else because they all have negative exponents. So the 2 to the negative 2 moves to the bottom and becomes 2 squared, or 2 to the 2. The c to the negative 4 also moves to the bottom and becomes c to the 4. And the last one, d to the negative 2, moves down to become d squared. Now, to complete my answer, I'm going to calculate out the 2 squared. So my final answer will be b to the 6 over 4 c to the 4 d squared. All right, so now I have an exponent on the outside of parentheses, so I know I'm going to have to use the power rule, but I also have a quotient. I have division on the inside because of that line. So like in the previous one, I'm going to look and see, is there anything that I can combine before I do that outer exponent of negative 2? So the quotient property says that I divide my numbers like usual, and then I subtract my exponents. So to begin with, I have 6 divided by 3, which is 2. And then I need to subtract my exponents. I'll go ahead and write out the intermittent step. So I have t to the 3 minus 2. So that's this exponent minus this exponent. And then I have d to the 4 minus 7. And that's all raised to the negative 2. Now I want to go ahead and combine my exponents and then distribute that negative 2. So I get, and I'm going to put a little 1 there to remind myself there's an exponent. So I have 2 to the 1, t to the 1 because of the 3 minus 2, and d to the 4 minus 7, which is negative 3. And all of that is raised to the negative 2. Okay, now it's time to distribute. So I have these 1s there to remind me that the negative 2 has to distribute to the 2 and the t. So I get 2 to the 1 times negative 2, which is 2 to the negative 2. T to the 1 times negative 2, which is t to the negative 2. And then d to the negative 3 times negative 3 times negative 2. So d to the 6. Again, it's not my final answer because I have negative exponents. So I'm going to go ahead and put this all over 1. And now I'm going to draw my line and place everything with a positive exponent. So d to the 6 is the only positive exponent I have, so I'm going to place that, d to the 6. And then the 2 to the negative 2 has to move down, so I get 2 squared. And the t to the negative 2 also has to move down. So that becomes t squared. Now my final answer is going to be d to the 6 over, I'm going to square that 2, so 2 squared is 4t squared. So again, that's your final answer, and notice there are no negative exponents. I would recommend pausing this and trying these 2 problems before watching the solutions just to see how you're doing with the process. And if you're able to get them completely right, that's great. If not, it may help you identify where you're still making mistakes. Okay, so for the first problem, I have 2 sets of parentheses and 2 different exterior exponents. I have a negative 3 here on the outside, and I have a 2. So I'm going to be using the power property a couple of times in this problem. Now, before I do that, I want to still look inside the parentheses and see if there's anything I can combine, which there isn't. There are no common bases, and there's only one number. So I can't do anything except distribute this negative 3. Now I'm going to place my 1 there for the reminder that there is an exponent. I'm going to do the same thing and look over here and see is there anything I can combine, which again there isn't. So I'm just going to go ahead and distribute. So that negative 3 has to distribute. So I get 2 to the negative 3, which again is 1 times negative 3, x to the 3 times negative 3, which is negative 9, y to the 4 times negative 3, which is y to the negative 12. All right, so I'm done with that distribution. Now I need to go do my next one. So I'm going to place my 1 on the 4, and then that distributes, the outer exponent distributes, and I get 4 to the 2, x to the 4, y to the 6. Again, that's multiplication. Okay, now I'm going to look and see if there's anything I can combine. The numbers, there are a couple of different ways that you could do it, but right now I'm just going to leave them in the form that they're in. Okay, so I'm going to leave it as 2 to the negative 3, and then I have an x here and an x here. Well, this is all multiplication, so I can use the product property, which says I add my exponents. I'll go ahead and write the intermittent step. So I have x to the negative 9 plus 4. So those go away. I'm done with those. Okay, and then I have y to the negative 12 times y to the 6. So I apply the product property again. Y to the negative 12 plus 6. And then I have 4 squared. Okay, now I'm going to go ahead and combine my the addition of my exponents. So I have 2 to the negative 3, x to the negative 5, y to the negative 6, 4 squared. Now I'm still not quite done because I need to flip everything that has a negative exponent. So remember again that this is all over 1. So I'm going to draw my line, and I'm going to place everything with a positive exponent. And there's only one thing that has a positive exponent, and that's 4 squared. So 4 squared is 16. So that takes care of this. And then I have 2 to the 3. That moves down. So down here. X to the 5. That also moves down here. Y to the 6. That also moves down here. Okay, now I'm going to go ahead. I've got a couple more steps. Again, there are a couple different ways of doing this, but I like to reduce the chances of mistakes. So the way that I'm doing it, I feel like results in mistakes less often. So I have the 16, and then I have 2 to the 3, which is 8, x to the 5, y to the 6, and now notice I have these numbers, and I can reduce those. So 16 divided by 8 is 2, so I have a 1 left over down here, I have a 2 up here, so my final answer, fully reduced, is 2 over x to the 5, y to the 6. All right, so for the next one, this is very similar to the one on the previous slide using the quotient rule. And we want to go ahead and combine everything that we can first and then apply that power rule with the outer exponent. So I can reduce my 5 and my 10. So I'm going to draw a line, and I get 5 over 10. Well, 5 goes into both, and I'm left with a 1 on top, which you can include or not, and then a 2 on the bottom. I then have x to the 3 minus negative 2. You have to be really careful of that. Another way to think about it is that you are flipping. You want to get rid of the negative, so you're going to flip the negative up here and turn it positive. So if you think of it that way, you get x to the 3 plus 2. Okay, and then I have y to the 2 minus 3, and that comes from here and here. And then I have a z to the 1, so z to the 1 minus 4. And all of that is raised to the negative 2. Okay, now again, there are a couple different ways of doing this, but I like trying to set it up so I do it the same way every single time. So I'm always subtracting the bottom exponent from the top. As you become more comfortable with this, you may establish your own patterns, but I find that this is a really good way for people to start. Okay, so now I'm going to go combine my exponents. So I'm just drawing my parenthesis and putting my 1 and my 2 in place. And then x to the 3 plus 2 is x to the 5. I'm done with those. Y to the 2 minus 3 is y to the negative 1. Z to the 1 minus 4 is z to the negative 3. And then I have my negative 2. And now I need to distribute that. Now this has to distribute to the entire quotient. Okay, so don't forget that the value on the bottom also has that negative 2 applied to it. So I have 1 to the negative 2, which is 1 to the negative 2. And anything, 1 raised to anything is 1. So that will eventually either become 1 or go away. And then I have x to the negative 10, which is my 5 times negative 2. Y to the negative 1 times negative 2, which is y to the 2. And z to the negative 3 times negative 2, which is z to the 6. And that is all over 2. Okay, that's still not quite done. We still have a negative exponent that we need to get rid of. Now remember, so I'm going to move up here for my final answer. So again, 1 raised to anything is 1. So that is just going to go away. I'm going to place my line and then place everything with a positive exponent. So my 2 is going to stay put. Okay, so I've now moved that. My y squared is also going to stay put because it is a positive exponent. And my z to the 6 will stay put because it is also a positive exponent. The only thing that I need to move is the x to the negative 10. And it's starting on top, so it needs to move to the bottom. So I have x to the 10. So that is my final answer with everything fully reduced and with all positive exponents.